Great. And now the next we have David from Approov, who'll be talking about API security from a mobile perspective. Hello, David.
Hi, Yannicka. How are you?
Good, thank you. How are you? Welcome to the stage.
Thank you very much.
So I'll let you kick it off. If you start with a brief introduction of who you are and what you're going to be talking about, and then I'll meet you here back on stage in about 20 minutes.
Okay, sounds great.
Enjoy.
Thank you. So I'm David Stewart. I'm one of the co-founders of Approov, and today I'm going to talk about mobile as it relates to API security. So I'm going to make a case that that mobile is actually one of your API security blind spots. We operate in this business every day. This is where we live and breathe, and so I'm going to bring in some of our observations and expertise into this discussion. So if mobile is if you're a mobile first company or mobile is an important channel to you, then this I hope will be interesting. So I'm going to go through, just talk about a high-level picture of API security and how it relates to mobile. Then I'm going to talk about what makes mobile different and special, and what kind of attacks we see against mobile platforms. Then we'll talk about what you can do about it, and make some recommendations at the end. So this is one of about 1 million different pictures of what an API architecture might look like, and where security might play in it. And we can argue about the building blocks in it, I'm sure. But the concept of the different kinds of remote clients, websites, mobile apps, IoT is probably consistent. We can argue about whether they come in on a single API or multiple APIs. But this is the kind of mechanism that we typically find with customers. And we've all enjoyed the growth in API adoption and deployment in systems over the last many years. But now we really need security to catch up, because it is already, and in actual fact, I'm referencing a Gartner report here, but there is an IBM report from this year that says their research was that 2/3 of data breaches were coming in through unsecure APIs. So APIs are a security problem today, and we really need to catch up so that we can take advantage of all the good things that APIs give us. So let me just pop into a little bit of detail on some of the boxes on this page. Looking at API gateways first, and again, of course, there are many different API gateways, but from a security perspective, the basic concepts of what an API gateway is trying to do is authenticate the user, authorize that user to access a certain subset of data and services, and to ensure that your backend systems can't be overwhelmed by a large spike in API traffic. So you've got some kind of rate limiting capability in there typically. But the question really is that that's all good and you should be doing those things, but does that imply that if an API request is successfully authenticated, is successfully authorized, and is running at a low frequency, is it automatically good? And sadly, the answer is no. Looking at the other big box on this, the WAF. WAFs, of course, come from the web side of the world and have evolved over time to support other remote clients like mobile apps and IoT devices. But the basic concept of what the WAF is trying to do is to look at the API requests and their content and try to scan for behaviors and signals that previously turned out to be bad activity. And so by its very nature, these kinds of, many of these kind of boxes are behind the curve. You really want things to be looking ahead and being able to, identify for sure that something is good or not good based on its current characteristics, not on historical patterns. And finally, and this is one that's not talked about so much when it comes to security, is cloud cost. So most of the backend systems nowadays are, of course, running in the cloud. And what that means for your business is that you're paying for every transaction that goes through any one of these boxes. And that's fine. That's how the business model works. But from a security point of view, it's very helpful if you can identify at the earliest possible time that an API request is not coming from somewhere it should be coming from, that it's somebody trying to enter the system who shouldn't be in there. Because if you can identify that as early as possible, then it means you don't have to process that traffic within your cloud system, which means that not only are you more secure, but you don't have to pay as much in terms of your cloud costs, which is no bad thing. So that's something else to think about when you're considering what kind of security arrangements you need. So let's dive into the mobile bit specifically. And this is a typical view of how you protect your mobile channel. And it consists of three pieces. The user, and you will have a range of user authentication mechanisms that you can use, from simple username password through standardized OAuth type systems, and may even have a flavor of biometrics in there as well. The API traffic itself will be encrypted using TLS, and that's obviously a good thing too. And then the backend will be protected using some of the boxes that we talked about previously, WAFs, API gateways, and maybe a CDN. And the basic concept here is you're trying to ensure that you check user credentials, and probably with the case of mobile, there's an API key involved, which most likely is stored somewhere in the mobile app and gets transmitted to the backend to prove that it's coming from the app itself. And what we're going to do shortly is look at the fact that this by itself is not sufficient. Let's look at mobile itself and how it all works, because it's a really interesting situation. Think about another example of a piece of software where we as developers spend a lot of time building it, making it easy to use, putting complex and rewarding business logic into it. And then we basically give it to anyone who wants to have it. And we don't control who they are. We don't control where they run it. We don't control how much they use it at all. And that's what happens when you go through the app stores. And I'm not suggesting that you don't want to do it that way. You have to do it that way. But what I am suggesting is that because that code is basically available to anyone for any time, then it gives the hackers great opportunity to uncover all kinds of interesting treasures about your business. And I'm not just talking about keys here. There's a lot more, and I'll come back to talk about this a bit more. The other thing about mobile that people don't think about is the fact that the app actually creates a sort of natural bottleneck in the whole process of data going to the back end. Because it's a single app, because it's probably got a single user logged into it, then that automatically restricts the data that can be reached via the app, and also the amount of data that will come back from the back-end systems. But as soon as you are able to connect a bot or a script to that API, if you're able to do that, and if it can successfully authenticate itself, then suddenly because the APIs are rich, much richer than a typical web page API, then it can extract a lot more data very quickly. And so these are the sort of characteristics that make mobile a little bit different, and why you need to think through the consequences of what you might be opening up. So this was the picture I showed a few slides ago about the simplistic view of protecting a mobile channel. What I want to do now is flip this on its head and say, let's look at this from a hacker's perspective. Let's look at how they see this particular picture. So the first thing they see is the mobile app, and they might think, great, I can take the mobile app and I can reverse engineer it. I can pull all kinds of keys and URLs and other user-related data out of the app. Potentially, if I can reverse engineer it, then I can maybe modify the app to do something slightly different, but it'll still look the same. And if I can get that repackaged and up into the App Store, maybe some users will download it in error to their devices. Now, if you've been smart, you've probably obfuscated your code in the mobile app, and maybe even you've hardened the app. And if so, you've done a great job, and you should do that. And that will make the reverse engineering much more difficult for the hackers to do. But The important thing to realize is that sometimes the hackers aren't actually interested in reverse engineering the app. What they really want to do is study it, is look at the data that comes in from the user, look at the data that comes out the other side on the API, figure out how they can manipulate what the app does to do something that they want to achieve. So just protecting yourself against reverse engineering is only one step in a number of steps. They'll also look at the mobile device and think about what they can do with the device. They've obviously got their own devices. They can use emulators and simulators to scale lots of virtual devices quite quickly. They can do auto launching if they want to, for example, run a whole load of apps in parallel on either real physical devices in device farms or on banks of emulators. They can do that. And they can also make use of instrumentation framework tools. I'm thinking about tools like Exposed, Frida, etc. And there are many of these. They're free. They're very good, and they really allow you to attach and get some real insight into what a running app is doing, to be able to manipulate its activities, to be able to modify the data that's in the app so that it's doing something slightly different from what the user is expecting, etc. There's a lot of those kinds of things that can be done. And the final piece that the hacker will look at is the channel. And so they'll get into the channel, they'll look at how they can man in the middle, or more politically correct, person in the middle, the channel, so that they can see the traffic, the requests and traffic coming by, and just learn about the traffic, or maybe manipulate it. I mentioned that you'll be using TLS, but it can be decrypted. And if you're going a step further and you're pinning your connections, which you should be, then that's good. But depending on how you've done it, there are ways to unpin using those kind of tools that I mentioned earlier on, to unpin those connections as well, so that the hackers can still get in the middle of the traffic. And probably most important of all these three slides is the scripting word, because the majority of attacks that we see, and main reasons that the hackers are looking at these areas, is because what they really would like to do is build a script that bypasses the app, connects directly to your API, but looks exactly like traffic coming from a genuine app instance. And if they can insert valid user credentials into that script, then the game is on as far as they're concerned. So that's really what they're trying to do. Is get scripts that begin to work. And why are they doing that? Well, I won't go through all of these, but these are a subset of the main attacks that we see in protecting our customers' mobile businesses. The account ones, account takeover, typical credential stuffing attacks, where credentials that have become available from other data breaches can be put into scripts and reused to open and take over accounts if users have used the same username and password, for example, in your platform that they use elsewhere. Then that's a risk. Fake account creation is very common, particularly within businesses that offer rewards for opening new accounts. Whatever the reward is, it doesn't have to be direct money. It can be vouchers, it can be anything, but if it's there, then somebody will figure out how to script up account creation and extract those rewards at scale from your business. And what other one will I mention? Scraping. So if you're in retail, scraping is a common one too. Think about your product catalog availability pricing being scraped in order to allow competitive solutions to be able to set their pricing just below yours, for example. And as I said before, the most important thing is that the majority of these attacks are executed via scripts, and scripts are the thing that you should be worrying about. So this is what the mobile channel should look like in your mind when you're thinking about how to protect it. Is that it actually has 5 surfaces, and not just the 2.5 that we looked at earlier on. And you really can't trust anything that's running between the end user and your own backend service. So this exposes the blind spot that was the title of this presentation, which really is the app integrity, the device integrity, and the channel integrity. And what you need to do about this is to shield them and make sure that they are what they claim to be. And if you can do that, then that can obviously keep the scripts and also impersonated apps out of your environment. So I'm just going to go through some ways in which you can do those, implement those three, shield those three areas. And I'm going to use Approov related mechanisms here, but obviously, you know, there are other ways to do this. But the basic idea here is to be able to be sure with every API request that comes into your backend that it comes with a signal that tells the backend that yes, this API request comes from a genuine mobile app instance that has not been modified. And this is not a once-in-time check that needs to be dynamic. In our case, we do it every 5 minutes, but you need to be able to authenticate that the app is present and the app has not been modified. And you need to be able to do that in a way that's invisible to your users, obviously, because they don't want any more friction. But also that it's done in a way that it can be repeated regularly, because those hacking tools that I talked about can be attached to a running app. And so it is important that you're checking on an ongoing basis that the app is still present and not being manipulated. Device integrity is a complex picture because there's a lot of different things that you need to check within the physical device and its operating system, and you need to be able to detect these things. Those tools that I talked about, things like root and jailbreak are the obvious ones, but there's a lot more than that. Debuggers, emulators, simulators. You want to be able to check for cloner apps. So cloner apps are apps that allow you to run 2 instances of a given mobile app on a single device. And you might think, well, so what? But actually, the way those cloner apps work is they do damage to the security mechanisms within the mobile. So in actual fact, in many cases, you really would want to detect and block them. So the important thing is there's a lot of different runtime things you need to check. And depending on what kind of market you're in, you will have a different set. So for some markets, rooted phones are okay. For some markets, rooted phones are not. So you need to be able to define your own security policy based on the detection of certain set of things. So if it's just root, then and you're a retail platform, then maybe that's okay. If it's root, but there's a Frida installation as well, then that's probably not good, etc. So you need to have that kind of level of granularity in the device integrity checks that you do. And for the channel, I already mentioned certificate pinning. Certificate pinning is the answer, and it's not a new thing. But what we hear from customers a lot is that it's considered complex to implement, not just to implement, but also to be able to manage. Because the thing about certificate pinning is that there will be times and reasons where you need to rotate your certificates. And what you don't want to be doing is having to reissue a new version of your mobile app when that happens. So a dynamic mechanism, in the case of Approov, we can do this over the air. So we can do it we can basically replace the certificate in all of your installed apps instantaneously. So it doesn't require you to have to reissue your app. And that's the kind of mechanism that you should be looking for, a dynamic certificate pinning implementation that does it efficiently and effectively. So coming to my recommendations, obviously, you want to be sure that, actually, before I get to the recommendations, I want to talk a little bit about API vulnerabilities, because I haven't mentioned API vulnerabilities. And I noticed looking through the agenda for this event that there's quite a lot of chat about API vulnerabilities. And I agree that API vulnerabilities are really important, and you should be looking to make sure you minimize or remove vulnerabilities from your API. But the thing that I want to point out is that everything I've talked about in this presentation, none of it relies on API vulnerabilities. So even if you don't have any API vulnerabilities at all, you're still open to the kind of attacks that I'm talking about here. Scripting attacks don't necessarily exploit API vulnerabilities. So if you can ensure that only genuine app instances can call your API, if you can check to make sure that those genuine app instances are running on safe devices, and you define what safe is, if you've implemented certificate pinning in an effective and efficient way, then you're in good shape. And I've added some resources here that you can find on our website if you're interested. I particularly recommend the Man in the Middle webinar, which is the third link down there, because there we go through in minute detail what Man in the Middle is and what you need to do about it and how dynamic certificate pinning works. Because if you're worried about certificate pinning, you should definitely watch that webinar. And then finally, you want to be able to take a look at what's happening in your install base of mobile apps so that you can see what kinds of attacks are being rejected, and if any new attacks and threats pop up, you can react quickly by changing your security policy, for example. So I hope that was helpful, and if you want to take any next steps on this, there's a resource page on our website which has got lots of white papers and videos and quick start guides and all kinds of stuff that you might want to dig through. If you want to speak to one of our security experts and ask them anything you like, you can do that either through me or just by signing up for demo, and you'll get to speak to one of them directly. And if you're so convinced by this presentation that you want to run a trial, then that's free as well. Okay, that was it. I'm happy to answer any questions if there are any.
Thank you, David. That was really good. Quickly, first, what's the best way for people to get in touch with you? Is it to go to your website or find you on LinkedIn, or?
Whatever's convenient to them. I'm open on LinkedIn. And the email address is in there. The website is approov.io, and there's lots of information there, including the full user documentation. So all of that's open. So there's more than enough stuff there.
All right, excellent. We're all tech-savvy people, so I'm sure people will find you somewhere. Quickly, we've got 1 minute. So I want to ask you, I hope this is not too big of a question. So you've spoken all about mobile being a blind spot. So what is the one thing that you would recommend everybody in the audience to ask themselves or go and do so they can go and check whether they do have this, whether they've been overlooking the mobile angle?
Yeah, so I think the question they should be asking themselves is when an API request comes in, if it looks like a genuine API request, that's great. But how would they know if that request was coming from a script as opposed to coming from a genuine mobile app instance? How would they be able to tell the difference, assuming that a script was able to impersonate a genuine API request? Okay.
Good. Perfect. So everybody who's listening, watching this, go and do that, do your homework, and then hopefully you'll be able to take away some of the learnings that David just shared to address those. Thank you very much, David. It was a pleasure.
No problem at all. Thank you.